Dear viewers, today I'm going to show the direct converter developed by RAM Electromech Private Limited. So in this part we will see the primary and secondary voltage and the inductor current, whatever we have seen in this waveform. Okay, primary voltage, secondary voltage, and the phase shift between these two, primary secondary voltage, and the inductor current with respect to the primary voltage. Okay, so we have turned on the system. Okay, we have set by using the auto transformer, we have set the 300 volt DC at the input side of the bridge one. Okay, and the output side we have maintained some voltage because it is in open loop. So whatever ratio we have given, we have just observed the voltage at the output side, and we have applied the load. This time we have set the load to 2.6 ohm. So up to the 14 and 15 ampere current we have drawn from here. Okay, so this system is off. Okay, now we have turned on the system. Okay, so you can see the voltage between the primary and secondary we have built here. Okay, and it is also gradually increasing. So you can see at the 300 volt input you can see the voltage is 28 volt. Okay, 29 volt something, and 11.2 ampere current is flowing at this time. Okay, and the primary voltage and secondary voltage is here. Okay, and now we can increase the phase shift between the primary and secondary, and you can observe the power is transferring from the primary to secondary. Okay, you can see the voltage is increasing, also the current is also increasing, and also you can observe the gate pulse primary and secondary voltage. Okay, so you can see I have applied the 20% duty. Okay, so you can clearly see the voltage is increasing to 40 volt, 28 to 40 volt, and here 11 ampere to 15.5 ampere current. And you can see the primary and secondary voltage. Yellow one is the primary voltage and secondary voltage is the blue one. So it is the primary and secondary voltage, and you can clearly observe the phase shift between the primary and secondary voltage. Okay, now we will observe the primary voltage and the current. Okay, so at the same condition, 20% duty, 300 volt input, 40 volt output, 15.6 ampere current, and 2.6 ohm resistor load, you can observe the primary current. Okay, means inductive current. Okay, so let's connect it and you can see. So now I have connected the primary voltage and the primary inductive current. Okay, so here I have connected the inductive current. Okay, so you can see the waveform. So 20% duty is here, 300 volt input, 40 volt output, 15.6 ampere current, and you can see the waveform, primary voltage and the inductive current. Okay, as you can observe the same voltage and current waveform here. Okay, so primary voltage and the inductive current. Okay, so likewise this you can observe here. Also you can increase the duty and you can see the current shape. Okay, also you can observe the voltage is increasing. Okay, so you can see the voltage and current. So based on likewise this you can observe the primary voltage and the current, primary inductive current. Okay, so likewise this you can perform one another practical, and you can observe all the gate pulses and the voltage and current likewise this. Okay, thank you. In the next part we will see the performance of the direct converter in the open loop mode. Thank you.